G'day and welcome to the third video on related rates, exercise 6.6 in your textbook. Now I've actually grabbed this question from the textbook, so you can have a look at their solutions if you want to, and I guess I'm just going to talk through the way that I would go about doing this. It's not as straightforward as the other couple, so we need to have a think about it. Let me just read it. An inverted cone of a base radius 6 centimeters and a height of 18 centimeters is being filled such that its height is changing at 10 centimeters per minute. Find the rate at which the volume is changing. So I guess what I've been given, I need to write all of these things down. My given, my want, and my need. The thing that I've been given is I've been given dH dt. And what do I want? I want the rate at which the volume is changing, so I want dV dt. And I know that that is just dH dt multiplied by dV dH. So what I really need is dV dH. Okay? So I need to find dV dH. Now I know that the volume of this thing is going to be pi r squared times the height and then a third of that. Okay, that's the volume of a cone. I could find out the volume of the total cone, but if this thing's being filled up, at some point it won't be full. It'll be actually only that big, or then it will only be, say, this big or this big. So I need to find out the volume at any such time. So I need to get dV dH, but the trouble with this, that's very sloppy writing, sorry. The trouble with this is that I've actually got an r in there, and I can't get the derivative with respect to h only because I have to deal with the r in some way. So what I'm going to do is I'm actually going to deal with that off to the right over here. I need to use something called similar triangles. I guess let me just draw the full triangle here that I've got. I've got that 6 and that's 18, and I've got this angle in here, theta, and that's a right angle in there. At some point it's only going to be this height. Okay, so at this point it's going to be r and h, and I don't know what r or h is, but I do understand that there's a ratio that's going on between these things. I don't know what that angle is, but I know that there's a similar ratio of this triangle here to this triangle here, and the way that I can tell that is because I've got two triangles. That's the big one, and this is the small one, and I know that that angle is the same. So I can say that these ratios, 18 to 6, will be the same ratio as this one, h to r. So what I can do is I can say that 6 over 18 is the same ratio as r over h. And then I can find out that r actually equals 6h over 18, which of course is just r equals h over, where did I go? h over 3. Okay, so that's what r equals. Okay, so I've used a process called similar triangles because I've based it on this base angle here, and then I've been able to work out, because it would be the same ratio, the height and the radius, and so I end up getting that the radius is always going to be a third of the height. Okay, so now I can, instead of writing dV dH, because that's the thing I essentially want to get, but before I do that, I'm just going to write down what V equals with respect to h only. So I get a third times pi times r squared, and remember that r is just h over 3, so it's h squared over 9 multiplied by h. So this ends up being pi h cubed on 27. So then dV dH, which is the thing that I actually want to get, is going to be pi h squared on 9. Okay, and now I can write down what's the actual thing that I need? So the thing that I want is dV dt. So dV dt is equal to dH dt, which is 10 multiplied by pi h squared over 9, which is 10 pi h squared over 9. And I now need to know what h is, and it tells me, no, it doesn't tell me, so I think that's all I need to know. So this is the rate at which the volume is increasing with respect to time. So this is my final answer just here. I guess, if you wanted to put centimeters cubed per minute, but I need to check all those things. Is it centimeters and it's minutes? Yeah, okay. So that's how to go about that kind of question. Sometimes you need to use similar triangles, particularly if it's a cone or something else that is disproportionate. You need to be able to cancel out or eliminate one variable with another. So hopefully that's made a little bit of sense. Have a look at your textbook. That also gives you a solution as well. I guess that finishes our video series on related rates. So thanks for watching.